G'day. In this video I want to introduce you to cubic numbers, and quite simply, knowing them will help you calculate more rapidly. They're used a great deal in algebra, particularly in calculus, in integration, when you're integrating quadratic equations. They crop up in calculations of volume and in probability and a range of other areas in mathematics. And just knowing your first basic cubes will save you from having to reach for a calculator. You can just know the answer straight away, and it's quite satisfying. What I'm going to do is introduce you to the cubic numbers and perhaps suggest ways you might remember some of them, and then I will show you a game or a pattern or a technique to learn the first 9 of them quite well, very well indeed, and have a modest amount of fun while you're doing it. But let's get going. A cubic number, by the way, is a number. We'll start with 0, make it really easy. When it's cubed, it means it's multiplied by itself 3 times. So we write it down 3 times and multiply it. This has got to be the easiest calculation you've ever done in your life, hasn't it? My favourite times table is a multiplication table, the 0. 1 cubed is just going to be 1 by 1 by 1. And 2 cubed, by the way, that's not 3. 1 multiplied by 1 is 1. 2 cubed is 2 times 2 times 2. 2 2s are 4, and 4 times 2 is 8. 3 cubed, 3 by 3 by 3. I'm not going to go all the way down like this. It'll be more tedious than I care to more tedium than I care to inflict on you, but 3 3s are 9 and 3 9s are 27. Now, just to illustrate, 3 cubed, for example, is a bit like dividing a square into 3 columns across and 3 rows. Multiplying by 3 again is like projecting it backwards in 3 dimensions and making a cube where you have 3 layers back as well. And I think you can see that if you've got 9 squares on the front, or 9 cubes on the front, and 3 layers of them, 9 by 3 is 27. Whenever I see 3 cubed, I think of Rubiks Cube. I don't know whether some of you are good at manipulating Rubiks Cube. It was a bit of a craze some years ago. But that's the number of cubes in a Rubiks Cube, including the one in the middle. 4 cubed is 64. 5 cubed. Now, every power of 5 ends in a 25. So 5 cubed is actually 125. I will actually show you this one, because 5 5s are 25 and 5 25s make this. Now, this calculation, I suspect students in the United States will do much more rapidly than students in, say, Great Britain or Australia or somewhere like that. The reason being that in the United States you have a coin worth 25 cents, a quarter. And you would know that 5 quarters makes $1.25. We don't have that coin here, so that's not something that our students understand quite so rapidly. Now, 6 cubed ends in a 6, and interestingly, it's not 1 2 but 2 1. 216 is 6 cubed. Every power of 6 ends in a 6. 7 cubed I like, because I like palindromes. These are things that read the same back to front. And 7 cubed is 3 4 3. 3 4 3, 3 4 3. And 3 and 4 add up to 7 anyway, with the big one in the middle. Just one of the numbers I happen to like. 8 cubed, 512. 9 cubed. Now I will show this one, because it's actually very rapid to calculate in your head. 9 9s are 81, and when you multiply that by 9, notice there's nothing carried. It's just 9 1s are 9, and 9 8s are 72. So 729 is 9 cubed. And 10 cubed, you should know 10 by 10 by 10, or at least calculate it quickly, because it must have 3 zeros in it. So we've reached a nice, neat, round 1,000. So they're the first cubes. I'll just remove that from there. I should remove this as well. Now, I would like you, I certainly want you to learn up to 9 cubed, and you should know 10 anyway, but the next two are actually worthwhile because they crop up with some regularity as well. And 12 cubed is 1728. Now, before we go on, I'm just going to share a little bit about these two and how I remember them. And the second one, by the way, helps me remember another one here. But let's talk about 11 cubed first. Whenever I see 11 cubed, I think of Pascal, Blaise Pascal, the French mathematician, and a thing called Pascal's triangle. Now, Pascal's triangle, which I'll show you in just a moment, is a brilliant tool for expanding binomial powers, or powers of binomial expressions in algebra, and consequently it's used an enormous amount in probability. So it does pay to become familiar with it. And all it is it's a triangle with ones on the diagonals and to fill it in, each number is the sum of the two numbers above it. Now, in a funny way, if you imagine all these out here as zeros, so you have to have a 0 out here, 1 plus 0 is 1, and 1 plus 0 is 1, and 1 plus 0 is 1. That's how we get the leading diagonal here. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 0 plus 1 is 1, 1 plus 3 is 4, 3 and 3, 6, 3 and 1, 4, 1 and 0, 1, and you could go on forever and ever. But there is an interesting little property that this triangle has. It has many fascinating properties, but this one I want to draw to your attention, and when I eventually create some videos about Pascal's triangle, I will explain why this is true. But 11 to the power 0 is worth 1. Anything to the power 0 is 1, but 11 to the power 0 is 1. 11 to the power 1 is 11. Just means you need one factor of 11, that's it. 11 squared, that's 11 times 11, is 121. And here's our number, 11 cubed is 1,331, our cube here. And by the way, if you want to know 11 to the power 4, that's 11 times 11 times 11 times 11, it's 14,641. So, when I'm thinking powers of 11, and particularly 11 cubed, I think of Pascal's triangle. And to be honest, I think every time this number crops up in my calculations, I have this fleeting thought of Blaise Pascal and his triangle. I hope it helps for you as well. Now, this number, whenever I think of that number, I think of another mathematician. This gentleman is French, so if you're from France, he's one of your compatriots. This next gentleman is from India. So if you're Indian, then you should look this man up, if you don't already know about him, on Wikipedia or something. Srinivasa Ramanujan, a most remarkable, talented mathematician. When I was in high school, I wouldn't quite call him a hero, but he was certainly a mathematician I admired. Mostly self-taught. He didn't have a lot of formal schooling. And as a young man, he worked in Madras or Chennai, and his friends influenced him or encouraged him to apply to study in Great Britain, and he applied to Cambridge University and was accepted. That's an interesting story in itself. He went there, he suffered quite some ill health, partly because of the English weather and partly he was suffering the after effects of dysentery. But once when he was ill, Professor Hardy, Hardy, Professor Hardy of Cambridge University, went to visit him by taxi. And when he arrived, he said to Srinivasa, "I came in taxi 1729. And he said, I'm this is nerd speak. He said, "I'm sorry I didn't come in a taxi with a more interesting number." And Srinivasa Ramanujan said to him, "On the contrary, this is a most fascinating number. It is the smallest positive integer, that is the smallest positive whole number, that can be expressed as the sum of two cubes in two different ways." Now we've got a whole lot of cubes written here, cubic numbers. And what he was pointing out is this, that 1000 plus 729 makes 1729. Well, that's not difficult. 1729, 1729. And these are these two numbers. So 9 cubed plus 10 cubed makes this number. But what Srinivasa Ramanujan knew as well was that this number plus 1 also made 1729. So it helps me remember that because it's one less than the sum of these two numbers. So because I know 729 well for 9 cubed, I know this is 1728. And also because I know that, it reminds me of the other. So for what it's worth, I hope that helps you. Now, I've pointed out some of the features as I've gone along, like the fact that 7 cubed reads the same back to front, and 3 and 4 makes 7, and 4 is in the middle. That 5 cubed ends in 25, and 6 cubed ends in a 6, and these numbers can be swapped. How simple it is to remember. 729 is 9 cubed, 10 cubed is 1000. I've shown you 11 cubed with Pascal's triangle, and how 12 cubed reminds me of Srinivasa Ramanujan. I didn't talk about 2 cubed, 4 cubed, 8 cubed. These ones I know because another thing I will encourage you to learn are your powers of 2. So if you start with 2 and keep doubling, 2, 4, 8, not 2, 4, 6, 8, 10, but 2, 4, 8, 16, 32, and just keep doubling, you will encounter these three numbers. So it's 2, 4, 8, 16, 32, 64, 128, 256, 512, and so the list goes. If we went to the next one, it'd be 512, 1024, 2048, and 4096. And 4096 is 16 cubed, which we won't go to. But if you know your powers of 2, that will help fill those gaps in. 27 I spoke about as being a reminder of Rubiks Cube. I've got some interesting mathematics about perhaps not so much the manipulation of Rubiks Cube, but the structure of those. I'm going to remove this now. I'm going to put the cubes up here on the side, only the ones from 0 to 9, because they're the ones I'm going to help you learn, hopefully with some rapidity, and have some fun while you're doing it. So let me remove this now, and then we'll get started. Now you can see I've got the cubes written up here. The game I'm going to show you is something that is quite simple to play. You just need to be able to add, and you will learn these numbers very, very quickly. I have a young lass that I'm teaching at the moment, or tutoring, in grade 5, and she already has learned this sequence using the same method that I learned them. So here it is, here's the method. You start with some number. As long as it's not a 1 with zeros, like 1 or 10 or 100 or 1,000, this will work. If you start with one of those numbers, it becomes very redundant for reasons that will become obvious when I show you. But the results we're looking for are in the hundreds. So they're 3-digit numbers. I'll give that away at an early stage. So it actually is simpler and shorter if you start with 3-digit numbers. Now we'll choose, let's say 429. Now I've learnt these, so this is blank here for me, but you can check against the numbers that I've written. What we do is we don't write equals, we draw an arrow, because what we're doing is not equal to 429. We actually pull it apart and we cube the 4 and we cube the 2 and we cube the 9. Now 4 cubed, we do use equals now, 4 cubed equals 64, 2 cubed equals 8 and 9 cubed equals 729. And here's where we practice our adding. 4 and 8 is 12, and 9 is 21, carry the 2, we get 8, 2 is 10, carry the 1, we get 8. We take that number and we do the same thing to it. So we start here with 801, and it becomes 8 cubed plus 0 cubed plus 1 cubed. Now 8 cubed, if you check over here, is 512. 0 cubed and 1 cubed are very easy. This gives 513. So we bring this number over and we play the same game again. Now we're looking for something, and you'll discover it very, very soon. In fact, I recognise where we're going now. 5 cubed plus 1 cubed plus 3 cubed. 5 cubed is 125. 1 cubed is 1 and 3 cubed. That's our Rubiks Cube number, 27. If we add these up, we get 7 1's 8 and 5's 13, carry the 1, 3, 5 and 1. And then I get 153, and we pull it apart, 1 cubed plus 5 cubed plus 3 cubed. I hope you've started to detect something already. 1 cubed is 1, 5 cubed is 125, 3 cubed is 27, and they add up to 153. And of course, if I bring 153 over and do it, this will happen all over again. So this is a number that cycles on itself using this game or this pattern of cubes. Now, it turns out that there are 3 others like it. So there's that one and 3 others. There are also some little loops, not many, but a small handful. But mostly, if you play this game, you'll end up at one of these 4 numbers. And the challenge that I give my students is to find the other 3 numbers. Sometimes I make it a bit more exciting by promising to pay them money if they find them. But that's a bit unusual for a tutor, I guess. But it's an interesting challenge or a game to find these 4 numbers, and I encourage you to do that. And already you see that we've been practicing a number of the cubes. They've been popping up already. Now I challenge you to find those same 4 numbers, or the other 3. Please don't list them in the comments under this video. If you do find them, leave that joy, if you like, for other students to find them. If you find the other 3, then by all means contact me directly. Just make a direct message, send me a direct message. But if you've enjoyed that, then please like the video or leave a comment, and certainly please subscribe so you can find out about future videos. But I recommend this to you. It's a great way to learn your cubes, and you will use them repeatedly during your high school career. Thank you for watching.